Good morning, everybody, from the Johnson Space Center in Houston, and welcome to today's briefing. We're going to be taking a look at tomorrow's activities as the SpaceX Dragon gets ready to be ungrappled from the International Space Station and begin its journey back to Earth. Joining me here in Houston is Holly Ridings, who is the lead NASA flight director for this mission. We'll also be going out to John Collaros out at SpaceX headquarters in Hawthorne, California, but we'll start off with Holly.
All right, well, good morning, everyone. Again, it's exciting to be here and discuss departure of the Dragon from the International Space Station. Before we get started on that sequence of events, I'll tell you a few things that have happened since last we spoke. Just a few days ago, last Saturday, after the successful capture on Friday, we did open the hatches and go into the Dragon. And of course, the crew reported that it really was an exciting time and looked great inside the Dragon. Gave the crew a little bit of time off, and then Monday earlier this week, we got right to work performing the cargo operations for this Dragon demonstration mission. The Dragon did carry some cargo up to the station to demonstrate that capability, and then we will be returning cargo as well. The crew worked out a plan amongst themselves very efficiently and managed to do almost all of the cargo operations in a single day. It took them quite a few crew hours, but just one calendar day to get that done, so we were very excited that they were able to do that when we're only staying attached to the station for this short 7-day mission. The next day, on Tuesday, we did have a little bit of cargo ops to finish up. And then today, currently on console, the team is working through the hatch closer, which happened just a while ago, GMT 13, so about 8 a.m. local time. And they're in the process of what we call de-outfitting the vestibule, that little space between the Dragon hatch and the Node 2 hatch, disconnecting some cables, putting back in the controllers that operate our common berthing mechanism in preparation for the unberth and the departure tomorrow. So those activities will take up kind of a remainder of the crew day today. The crew is going to bed a little bit early today because tomorrow morning we're going to wake them up 2 hours earlier than the nominal time, so that's GMT 0400. In terms of the day itself, big picture wise, tomorrow we are kind of optimizing our release and departure from the space station for the Dragon SpaceX team to give them the best opportunity for this test flight, for this demonstration, for the Dragon to come home successfully. And John will talk in a few minutes about some of the items that they've optimized on their side in terms of their re-entry sequence. So going back to the departure tomorrow, the crew's waking up at 0400 GMT. They'll get right to work after just a few minutes, finishing up again, the de-outfitting of that vestibule area, so cleaning up the very last power jumper that we're leaving connected overnight tonight in order for the Dragon to remain on station power. So they'll finish that up. They'll go ahead and close the Node 2 hatch. Then they've got a significant amount of time, a couple of hours, to depress that vestibule, that space between the Dragon hatch and the Node 2 hatch. When that's completed, then they'll step into their CBM operations. We did take the robotic arm back to a position where it's already grappled to the Dragon. One other activity that happened since Dragon was attached last week, we did do an external survey of the Dragon, of the trunk space, the solar arrays, the outside of that Dragon to gather a bunch of data for this demonstration and this test flight for future flights. So we took the robotic arm after that activity and back grappled to the Dragon where it is today. So after the CBM activities, the crew will be able to step right back in to the robotic arm activities, a series of maneuvers. You do the unberth from the space station CBM, and then you move the arm out to a release position. The release itself is targeted for 0935 GMT. Certainly with this test flight, this being the first time we've run through that series of activities that I just described, there's some variability in that time, but that is our timeline time that we're targeting, the 0935. The departure sequence is fairly quick. It's a 3-burn series, 2 small burns, and then 1 big burn. So turning on the Dragon engines, and the Dragon will head away from the space station outside of of the integrated space, and that'll be the end of our integrated activity with the SpaceX Dragon team, and that process is 10 or 11 minutes after the release time. So again, very quick, very different than Rendezvous Day when we spend a lot of time in integrated space. The Dragon will head on out and then be on its own in terms of the Dragon team controlling and managing the rest of the activities for the day as they work through their reentry and splashdown sequence. And so with that, I'll hand off to John, and he'll walk you through all of those activities that his team will be managing.
Hey, thanks, Holly. Yeah, so Holly perfectly described our departure sequence. Once we leave integrated space from the space station approach ellipsoid, we'll be conducting numerous operations, which include closing our G&C bay door. That door is where the grapple fixture is located, where station grabbed us with the arm. So we'll be closing that up, performing some checkouts, and then performing our large reentry burn, which will take about 10 minutes. And with that, about 5.5 hours after release from the arm, we should be in the water. Our recovery forces will be standing by. They departed late Monday night, and they're about 16 hours out from the splashdown zone, and they'll be ready to recover. Now, it's important to note, again, we have a lot ahead of us on the SpaceX side. Once we leave integrated space with NASA, we still have the entire reentry to perform. We're really looking forward to it. We've done it once on C1, but it's still a very challenging phase of flight. And only a few countries have done this before, so we're not taking this lightly at all. But the crew looks good, and we should be ready for it.
Okay, we'll take some questions now here in Houston first, then we'll go to the phone lines. We'll start over here with Mark.
Thank you, Mark Carreau for Aviation Week. I think my first question is for Holly. Holly Ridings. When does the sort of the NASA operational phase of this flight end? Is it with the ungrapple, or is it a point down the line? I just kind of wanted to see where you consider the demarcation.
Okay, it's actually, as John mentioned, when the Dragon exits what's called the approach ellipsoid. So that's the 1 kilometer by 2 kilometer radius. If you did diameter, it's 2 by 4 kilometer space. And so to go through the burn sequence one more time, you do the release. There's 2 small departure burns Dragon performs that you kind of go down the R-bar, sort of directly towards Earth, and then a larger burn that takes you out of the approach ellipsoid. So roughly 10 minutes, if I look at the timeline, I think it's exactly 11, after release, we'll be outside of the approach ellipsoid, and that is the end of the integrated operation portion. So per our flight rules, outside of the approach ellipsoid, on a safe trajectory away from the space station. We do continue to support the Dragon team with TDRS scheduling and communication for them, but in terms of the authority, we're outside of the integrated space, and then we turn into a supporting role for their mission at that point.
Okay, and if I can ask a follow-up, I have one for John. Could you, as accurately as you can, describe where the recovery zone is, and during the reentry, can you explain how you'll do your tracking? In other words, do you have more than ships for the recovery? Do you have any aircraft involved? And once you bring Dragon aboard the recovery ship, can you explain where you'll take it next? Is it Hawthorne for de-stowing and refurbishment?
Certainly. Hopefully I can remember answering all your questions. So first, our splashdown zone is about 490 nautical miles southwest of Los Angeles, more to the west and south. The recovery boats, it's a fleet of 3 vessels. I'll be standing by for that, with then supporting fast boats that go out and safe the spacecraft. We expect to return the capsule. It'll take about maybe 2 to 3 days to return, and on return to port, we'll then go directly to our facility in Texas for cargo unloading and for further spacecraft inspection. And I'm sorry, you had a question about tracking, I believe, as well. So we have a number of ways that we track position on Dragon after the reentry burn. First, we have 4 inertial measurement units that are providing updated positions. Those are updated by our GPS units that are on board the spacecraft. These all communicate with us via TDRS connection, as Holly had mentioned, using the NASA assets there. We also have a number of ground stations that will pick up Dragon during its descent. And then a telemetry dish is also a part of the recovery vessel. So we have kind of a mini telemetry vessel out there. It'll be tracking Dragon all the way to the water. Furthermore, we have a separate recovery system that it consists of another GPS system that uses a different communication system to relay to us globally where Dragon would be in the water. Your final question, could you repeat it?
Yes, sir. I wondered, you mentioned that the recovery ships will come to a port, and I didn't know that was Hawthorne, and then you fly it to McGregor in Texas, if I understood you correctly. I just wondered if you could sort of clarify the full voyage of SpaceX, or where you take it. I'm not clear.
Sure. So we recovered Dragon onto our recovery vessel. And then from there, we bring it into the Port of Los Angeles and then immediately transport it to our McGregor, Texas facility. You'd also asked about aircraft. We currently have a number of aircraft supporting. We have our own jet that will be standing by, but we do use the NASA P3 assets. One is an infrared imaging aircraft, and the other is a telemetry aircraft. These are same aircraft that were used for shuttle return flights. Very capable assets, and they'll be standing by and capturing Dragon during the reentry all the way to splashdown, just like what they did to support us on the Dragon C1 mission.
Okay, Robert.
Hi, Robert Perlman with CollectSpace.com. With a question for John, maybe also for Josh. You mentioned having aerial imagery assets. What might we see during the actual reentry and splashdown?
I'll let John take that one first.
So the assets we have on the aircraft, it's primarily infrared. So it's trying to capture Dragon during the reentry process. So you'll see various heating profile on Dragon itself at a rather long distance, but still enough for us to get some good data from. And then on the recovery vessels themselves, we also have high definition video and still camera photography, as well as a telemetry asset. And that will be capturing Dragon onboard video, but that video is primarily just of the interior of the cabin.
Okay, and a second question for John. With regards to the NASA cargo on board, what's your timeline for once the capsule's back in McGregor for delivering the payload back to NASA, and how does that compare to the timeline for an operational CRS flight? Thank you.
Certainly. So we have 2 types of cargo that we have requirements to deliver back to NASA, and we're going to be demonstrating the early access cargo return, which is a pretty special return profile that wasn't normally meant for this mission, but we'd like to demonstrate it, and that's to get high-value experiments back to NASA within 48 hours of splashdown. So that's a stretch goal for ours, but we are going to exercise that and turn that over to NASA within 48 hours after splashdown in Los Angeles. The second requirement is to return standard cargo to NASA within 14 days, and that we should definitely meet with the turnover occurring in McGregor, Texas, which works out well for NASA because most of the processing for the payloads will be occurring out of Johnson Space Flight Center in Houston.
Okay, over here.
Yes, I'm Ford Atkinson with KRIV here in Houston. I wonder, just for the layman, so they can understand better, and me too for that matter, what have you learned so far, perhaps that you didn't expect to learn quite this early in the mission? Has something occurred that you said to yourself, wow, that was easier or more difficult than we thought it would be?
Well, let's see. In terms of learning, you're constantly learning. We spent, in John's case, 5 or so years, in my case, almost 3 years designing all of these activities. And so to see them run, you're always learning things. I'm trying to think of a good kind of high-level example. Certainly the rendezvous and capture, John and I worked through that together, and so to see how Dragon was going to behave as it's moving towards the space station with all of the sensors that communicate with the space station and determine, the location of the Dragon and the location of the space station. So we all learned a lot about how those are going to behave, and I know that post-flight, the SpaceX team is going to look at those in a lot of detail. We learned a lot about how the Dragon's going to behave when the crew captures it, right? So you have all of this analysis ahead of time that says when you turn off of the engines and it sits in that spot where the arm reaches out to grab it, how much is it going to move around? And so that analysis told us that it was going to move around a little bit. And actually, I think I'd have to look at the telemetry, but to my eye, it looked like it did very well and met the expectations and was very good for the crew to go and grab it. So that was one thing that at least I was concerned about ahead of time, because you want to make sure it's going to move in a little and sit in one place so that the crew can grab it. So to me, I learned that. So we learned how the vehicle behaved. The other big thing, we really learned how we'll work together as a team. And overall, that went very, very well. There are differences in the way we do operations, of course, differences in the structure of our control center, but mostly we learned that to bring in a new partner, the SpaceX team, we were able to communicate and accomplish something very complicated in space with two dynamic vehicles. So those are probably my two biggest ones. I don't know, John, you have anything to add?
Just to reiterate again, how well the teams work together and the value of training really allowed us to ensure success for the approach and the berthing operation. Also, just like how Holly mentioned, the behavior of the vehicle was as expected, and that was a big confidence boost, again, to reiterate how good our analysis was on it. And honestly, we also learned that, at least I learned, I have no trouble sleeping during the day. The shifts were great. Shift schedule worked really well, and the crews, both on the NASA side and the SpaceX side, really were strong.
Okay, let's go to the phone lines. I believe we have Ken Kramer with Spaceflight Magazine. Okay, let's go to the phone lines. I believe we have Ken Kramer with Spaceflight Magazine.
Hi, thank you. You did a survey of the exterior of Dragon. I wonder if you could tell us a little bit about the results of that, please.
Okay, well, we only finished it up just in the last 24 to 36 hours, so the results are very preliminary, but overall very positive. One of the primary goals of the survey was to ensure, again, that all of the models in the analysis performed on the ground really matched the on-orbit configuration of the Dragon. Downstream flights, we're going to do robotics, where we go out into the trunk. So we take our robotic arm and we put Dexter, so the SPDM, on the end of the arm, and can reach around in the trunk and grab different payloads that SpaceX brings to the station. That activity is done what we call kind of in the blind, where you're reaching around on the back side. The crew doesn't have a good physical view out of the cupola windows. We use cameras, and so it's really important that all of the models are accurate in terms of all of the clearances, to put the arm into the trunk, pull the payload out of the trunk, put payloads back into the trunk. So that was really the biggest goal. The results were very positive. They need to take all that data and go match it in detail to all of the computerized models. The other goal was really to just get a general understanding of how well the Dragon had performed, take a look at the solar arrays, look to make sure on the trip to space station there was no damage that might cause a problem when re-entry happens here shortly. And again, all of that was very positive. There wasn't anything specifically identified that could cause a problem, although I know everybody's still pouring through that data in great detail. But the initial thought is that the Dragon really looked great.
Great. If I could ask a quick follow-up for John, could you describe the size of your SpaceX team, mission control team, please? And I guess you work 24 hours a day?
That's correct. We have 4 total shifts. Usually it's 3 working 8-hour shifts. Each shift, depending on what phase of flight, can flex anywhere from 4 people on console up to the 24 seats that we have there. Now, of those 24, some of those are roles like safety and mission assurance and quality control. The main operators probably take up about 15 to at a maximum of 17 operators, and those include some very specialized roles for this one test flight. We want to be making sure we had the experts in the room in case we had any items we want to look at. And for future follow-on missions, CRS missions, the team would generally go from 4 operators during low times such as far-field rendezvous or even berthed operations, getting down to 2 crew members, and then all the way up during rendezvous ops between 8 and 12.
All right. And I just wondered, too, if you had a chance, I asked this earlier, to take a picture with all 6 crew members together in the Dragon. Thanks.
Well, let's see. So I'm pretty sure there's a picture with 3 crew members in there. I haven't seen one yet with all 6. We'll check and see if there is one. You know, the Dragon is, with the cargo in there, not really enough space for 6 of them to be in there comfortably. That doesn't mean they haven't given it a try, but I haven't seen a picture yet. So at least so far, the only one I have seen is 3.
Thank you.
Okay, thanks, Ken. Let's go to Roger Ball with BBC Radio.
Good morning to you. First of all, a question for Holly, and then I'd like to follow up with one for John. When you had a look at the outside of the Dragon, did a survey, you had a look inside the trunk. I presume that you didn't come across any anomalies that would cause problems recovering cargo from there.
Yeah, so certainly from our perspective, there were not any anomalies. And just to clarify, for this mission, NASA did not put external cargo in the trunk. That's planned for a follow-on mission several flights downstream from now. But this was really all the preparation work to make that successful.
Right, thank you. And a follow-up question for John. The recovery vessel, is this a SpaceX vessel? What size is it, and what sort of weather constraints do you have for recovering Dragon from the sea?
Certainly. So SpaceX contracts with a commercial provider for the recovery vessels, and that allows us to have a lot of flexibility in case we need to call up a different vessel because of scheduling concerns. The operators that we use normally operate a vessel in about the 140-foot range, and then supporting vessels are slightly smaller than that. And the vessels are meant for oceanic voyages and so forth, so they have very high sea state constraints. And our recovery constraints are about, to put it in terms of past programs, slightly higher than the Apollo sea state constraints. And right now, weather is looking great through, forecast to be great through the recovery time plus some margin for the following 7 days after splashdown.
Okay, I think that's it from Roger. Let's go to Clara Moskowitz, space.com.
Thank you very much.
Yes, hi. I'm wondering if you can tell me if there's any chance at all that the space station crew will be able to see re-entry from orbit, and also if Dragon is going to be flying over any parts of the land in pre-dawn or darkness where people on the ground could see it.
Okay, well, I'll take the first part. I actually just talked to the space station crew this morning. We were doing our last robotics training session, and after that we had a little debrief, and one of the things we talked about was potentially trying to see Dragon. So the release time itself right now is in the dark. However, what they can really see is a plasma trail, and so if you plot out the time of the plasma trail, it's in the daylight, which will make it pretty hard for them to see. Although I will tell you, in the control center right now, they're sending up the information to the crew so they know where to look just in the off chance they can see it, although we think it's unfortunately pretty unlikely just because of the daytime.
Okay, thanks.
Okay, Irene Klotz with Reuters.
Hi, thanks very much. I have a couple questions. First, a quick follow-up to John on one of the previous questions is what's the name of the company that's going to be doing the recovery?
Certainly, it's American Marine out of Los Angeles.
Thanks. And For Holly, how important is it, do you think, for NASA to get a big return load, since it's been nearly a year since the station programs had this capability?
Well, in terms of return cargo, because this is the test flight, specifically the program made sure that there's not anything coming home that we couldn't afford to not get back. Certainly that is not the plan. John's team's going to have a great reentry and splashdown, but we didn't put any critical cargo on the return manifest. That being said, I know it's a really important capability to prove for NASA and for the space station program as we go forward, since this vehicle has the unique capability to return cargo.
Thanks. And the last question I had is, I assume the surprise is over now. Can either of you tell us what was aboard Dragon for the crew, just kind of the care packages? Thanks.
Let's see. So I talked to them this morning, but I actually didn't ask them that question. So I don't know. John, do you know?
Actually, I was going to defer to you, Holly, on that one. So I don't have that information either.
Yeah, so generally, we keep it private, and we don't really delve into their care packages. That's kind of what makes them special. So I didn't actually ask them, and don't know the answer for you.
Thanks. Gwen Shotwell had said before launch that they had asked for apples, but they decided not to include them because of they didn't want them to rot in between. So just was curious if there was anything like that, but that's fine. Thank you.
Okay, thanks, Irene. Let's go to Marcia Dunn with the Associated Press.
Yes, hi, this is Marcia Dunn with a couple of questions for John. Is this spacecraft in particular going to refly again, and if so, when?
Okay, NASA has contracted all new Dragons for both the COTS, Commercial Orbital Transportation Services, and the Crew Resupply, or CRS missions. So this vessel and then the 12 follow-on spacecraft will all be new builds. We do have the capability to refurbish and refly Dragons, both to other destinations. So if there is a commercial desire either to go to a different space station or for eventual crew carrying capability, we could look to refurbish these capsules. And also we have a vehicle called Dragon Lab, which is a long-term free flyer where we can fly experiments up to 2 years on orbit that do not go to the International Space Station. And we may refurbish these capsules to fulfill that role.
A couple more questions then. What will happen to this Dragon in particular? Will you put it on display in Hawthorne, or use it for parts?
I don't have that information, but it will definitely be on display for its history-making the history-making aspect of this mission.
My last question for you is, how would you measure this mission if you don't get the Dragon back the way you hope? How would you assess the mission then up to this date, if everything goes well tomorrow and if it does not?
So first of all, it was a major success for us. The ability to first combine the C2 and C3 missions and the trust and hard work that NASA helped SpaceX with were really important. And the ability to get to space station on our first time, to not only rendezvous, but then to berth, transfer cargo, and depart safely are major mission objectives. And we would call that mission alone a success. Every other spacecraft short of Soyuz fulfills that exact role, where it delivers cargo and then has a destructive reentry. We're hopeful, again, it's a major challenge tomorrow that we feel we're ready for to perform reentry. But regardless, this C2 Plus mission has been a major success for SpaceX and for NASA.
Thank you very much.
All right, thanks, Marcia. Let's go to James Dean, Florida Today.
Thank you. A couple questions for John. John, could you describe the heating and G-forces Dragon will experience during reentry, and possibly compare that to any other vehicles that have reentered? And is it the same profile as if you would anticipate if you were flying people?
It is the same profile that we would anticipate flying were we carrying crew from the International Space Station instead of cargo. Right now, because of the inclination and the ISS altitude, This reentry profile will be similar to the C1 profile that we already flew, and we saw very, very strong results on Dragon. So we don't anticipate anything atypical from that. With standard heating, again, similar to most vehicles that have reentered, including shuttle, with the exception of some variations on shuttle's profile. But again, very standard for the inclination and altitude of space station.
So that would be perhaps up to about 3,000 degrees, the heat shield will deflect?
I'd actually have to get you that number. I don't recall offhand, but that does sound roughly correct, and as well as Gs that are well within the crew limits. Again, the cargo version of Dragon is designed to fulfill as many crew carrying capabilities as possible, and that includes the G profile.
Okay, thanks. And I was wondering if you could possibly just explain a little more why, given the different factors you wanted to optimize, why tomorrow is the best re-entry day for you. And then finally, when do you expect the next Dragon to ship to the Cape and be ready for flight?
Certainly. The reason why tomorrow is optimal for us is it gives us the maximum amount of daylight in the recovery zone. So that gives the recovery crew a great opportunity to get Dragon on board the vessel as quickly as possible. Also, in the morning hours, we expect sea states to be a little bit lower than they are as the day goes on. So this is really a prime opportunity for us. And I'm sorry, your second question?
When will the next Dragon to fly be? I understand the Falcon 9 is already at the Cape. When will Dragon be shipped and be ready to go for CRS-1?
Yes, that's correct. Falcon 9 is at the Cape, and it looks great right now. In fact, it's completing checkouts at the Cape for the next mission. The Dragon is for CRS-1 is here in Hawthorne right now, and we expect that to ship early Q3.
Okay, thanks, James. Let's go to Charles Atkinson.
Good morning, Charles Atkinson, Examiner.com. Holly, what key tests does NASA have planned for Dragon following unberthing?
And the question was what key tests? Was that the question?
Yes. Does NASA have any new or key tests that they want to try prior to re-entry for Dragon?
We actually have already completed all of what we called our demonstrations, or as you termed them, key tests. They were really planned for the fly under and then on rendezvous day. Obviously, the cargo transfer was a key test in terms of fulfilling Dragon's capability to transfer cargo. And so once we do the release from the robotic arm, and then, as I mentioned earlier, the Dragon does its departure sequence, its 3 burns out of the approach ellipsoid. We don't have anything else planned for this mission. I know that the team will be gathering a lot of data because a lot of the sensors and systems on Dragon will be used again as it was during the rendezvous sequence, but we've actually already completed all of our key tests for the flight.
Thank you, Holly. And John, I've got a couple real quick. How is Dragon's fuel levels following its extended approach for docking?
So Dragon is looking very good. We're above our margins for nominal reentry, and we're tracking closely with Holly's group for release, but we're still above our minimums and above our profile.
Okay, what is the name of the recovery vessel?
I don't have that information. We have a number of vessels that we work with, but we can get that to you later if you'd like.
Okay, that'd be great. And then one last one, thank you. Will SpaceX ever consider naming future Dragons with a nickname?
That question you'd have to ask Elon, so I can check with him, but right now this Dragon is a C2 plus vehicle, and the next vehicle to fly, Dragon 3, is going to be fulfilling the CRS-1 role.
Okay, thanks, John. Congratulations on a great flight.
Thank you. I really appreciate it.
Okay, I think that is all any follow-ups here in Houston. Okay, Mark.
Thanks again, Mark Carreau for Aviation Week. I wondered about the early cargo that will be taken from Dragon and presented to NASA, I guess, in the Los Angeles area. Is any of that some of the medical specimens that have been accumulating on the space station, or is there some way you can sort of describe the nature of what's early material to get, or is it simply just demo stuff that isn't perishable?
Okay, well, it'd probably be better to get you the specifics off of the manifest. From what I can remember looking at it yesterday, we went into Dragon and took some samples of the environment, grab sample as an example, and so that's one of the early DSTO items so that the team on the ground can start analyzing that immediately and make sure everything was as we expected. And in terms of medical samples, I think it'd be better if we check the manifest and then we'll get you that information.
Okay, I think that's it. Let's take a look at our programming coming up early tomorrow morning here on NASA Television. We'll have the ISS update later on today at 10 o'clock Central Time, 11 o'clock Eastern Time. And as you heard Holly talk about, the crew is going to wake up bright and early later on tonight at 11 p.m. Central Time, midnight Eastern Time. Our coverage will begin at 1:30 a.m. Central Time with the unberthing of the Dragon spacecraft from the International Space Station. That time right now set for 3:05 a.m. Central Time for the robotic arm to detach Dragon from the space station. And then the actual release will take place at 4:35 a.m. Central Time, 5:35 a.m. Eastern Time. We'll have another edition of ISS Update early tomorrow morning at 8 a.m. Central Time, 9 a.m. Eastern Time, and then our live coverage will continue at 9:15 a.m. Central Time for the deorbit and splashdown coverage. Right now, the deorbit burn is scheduled for 9:51 a.m. Central Time, which of course would be 10:51 a.m. Eastern, and then the splashdown targeted for 10:44 a.m. Central Time, 11:44 a.m. Eastern Time, and then we'll have our final mission status briefing from here in Houston and also in Hawthorne at 1 p.m. Central Time, 2 p.m. Eastern Time. So please join us tomorrow for the conclusion of this historic mission. And of course, for all the latest information, just log on to the NASA website at www.nasa.gov/SpaceX or /station. ISS Update is up next here on NASA Television. We'll see you back here tomorrow morning.